and welcome. My name is Partha Majumdar. In this video, we will discuss an example of solving linear regression problems using Scikit-Learn library. In this video, we will demonstrate one example. We will use a data set, which is a data set which contains the sales of different products. And for against the sales, we have the data regarding how many advertisements for the sales were placed on television, radio, and in newspapers. So we will see two models. One, we will build a model using one variable. So when we build a model using one variable, we should get an equation something like this: y is equal to ax plus b, where y is the dependent variable. In our case, it will be the number of sales made, and x will be the independent variable, which is the variable regarding number of advertisements. So we will take an example where we will see how the number of advertisements in a television can be utilized to predict the number of sales. So X will be number of advertisement placed on television and Y will be the number of sales. Once we have made this model, then we will make a model using more than one variable. That is, we will take the number of advertisement placed on television, radio, and newspaper. So we'll have three independent variables, X1, X2, and X3. X1 being number of advertisement placed on television, X2 being number of advertisement placed on radio, and X3 being number of advertisement placed in newspapers. So based on the data which we have regarding these combinations for these three values of X1, X2, X3, we have the value of Y. So based on all the data points that we have, we will try to make a model. Then we will give a new value of X1, X2, X3, and we will get the number of sales what is predicted by our model. So this is what is a linear regression problem we will solve. Let us get ahead with it. So first, let us load the libraries, what is required. So we will require primarily only the pandas library. And we will make a few graphs. So we will use matplotlib for that. So let me just run this. So here the libraries are getting loaded. Now the libraries are loaded. The first thing we'll have to do is to load the data. Our data is present in this file called advertising.csv. So you can see this file here. So if I open this file, you can see that it has got this data. It has got the number of advertisements placed in television, radio, and newspaper. And corresponding to these values, the number of sales recorded is so much. So now let's get back to our notebook. So I will use pandas to read the CSV file into a data frame. And let us see the data frame, what it looks like. We will see the first few records in the data frame. So this is what our data frame looks like. So the first 5 records are shown here. So this is the first 5 records. Now, what we will do is that, so let us see how many records we have. So if I say df.shape, it tells us that there are 200 records and 4 variables. So the 4 variables we have already seen. The 4 variables, 3 are the independent variables, that is this ones, and this is a dependent variable. Now let us make our linear regression model using one independent variable. So what we will do is that first we will make a linear regression model where we will use the number of advertisement placed in the television as our X, that is an independent variable, and we will try to determine the Y, that is number of sales that will generate. So for that, so here you notice that I am making X as equal to the number of televisions, advertisements, and Y as the number of sales recorded. So let me make this data set X and Y. So there we have it. So if you want to see this data, so if I say X, notice that it has got only the records, only the data regarding number of advertisements placed on the television. And similarly, if I see Y, this has got the data regarding the number of sales recorded against the number of advertisements placed on television. Now, there are 200 data points that you can notice here. we will split this data into training set and test set. So we can use the train test split function from the scikit-learn library, that is scikit-learn sklearn.model selection. We take the train test split function. So to the train test split function, we pass our x and y, that is this data set what we have created, x and y, and we say that keep 20% aside for test and remaining 80% use it for training. So this function returns us four data frames. One is the X train that will contain the X of for the training data. And next is X test that will contain the X for the test data. Y train will contain the corresponding Y values for the training data, and Y test will contain the corresponding values for the test data. So let us run this. So now the training set and test set is created. Let us see how many data points we have in training set and test set. So notice here that we have got 160 data points from training set and 40 data points in the test set. Now on the test set, let us draw a XY scatter and see what the data looks like. So here you notice that I've created XY scatter on the training set, and you can see that clearly there is some kind of a relationship between the number of advertisements placed on TV and number of sales made. Because as the number of advertisements are increasing, the number of sales also seems to be increasing. So this is a good data to model for a linear regression. Let us see how to model that. To model the linear regression model, we can use the linear regression function in the scikit-learn, that is sklearn.linear model library. So we first instantiate the linear regression function and we take it in a variable called LR. Then we will fit the model using the training data. So this is the training data. As it is a series right now, because there is only one variable, we have to do a slight reshaping of the data. And we give him the corresponding Y labels, that is the Y train. So let us fit the model. So once we fit the model, it will give us an equation of the form, that is sales is equal to a constant called A0 plus a constant called A1 into number of TVs. So A0 is known as the intercept and A1 is the slope. Slope basically means that for every unit of increase in the number of televisions, what is the increase in the number of sales that is recorded. So that is the slope. So let us see what is the intercept and the slope. So this function, so this attribute coef, this gives the slope. So when we say the linear regression model dot coef, it will give us the slope. So this is the slope what we have got. This means that for every unit of increase in number of advertisements in television, the amount of sales increases by 0.05 units. And the intercept is 7.007. So this basically means that if we place no advertisements, then we will still make a sale of 7 units. Let us plot this linear regression line on our graph and see what it looks like. So here we are plotting the linear regression line on our graph. So notice that these are our data points. The data points are in red. And passing through the data points is a linear regression line, that is this one. That is this blue color line, what you can see. So now you notice that the linear regression line is not exactly predicting all the data points correctly, because you notice here there is a data point here which basically says that the number of television advertisements is this much and the number of sales recorded is this much. Now, however, for the number of television advertisements at this much, our model is predicting the sales number of sales to be here. So this distance, what is between this actual number and the predicted number, this is the error. So this error is produced in almost all data points. Now what we do is, you notice that sometimes error is positive, sometimes error is negative. So here the error is positive, whereas here the error is negative. So if we take the errors as it is, then the errors will negate each other. So instead what we will do is that we take the errors square. So when we take the error square, then it gives a measure for us as to what is the degree by which our model is making a error. Anyway, our linear regression line here shows that the sales is equal to 7.007.0 plus 0.055 into number of televisions. So you can see here, this was the intercept and this is the slope. Now, using this model, if we have to make a prediction, we can make a prediction. So for example, supposing I say that number of television advertisements is equal to 55. Then what is the number of sales that we expect? So in that case, we can write the formula as number of sales expected is equal to, our equation was 7.007 plus 0.055 into 55. So we can calculate this using Python itself. So we can just put this as an equation in Python. So I can write here and let us execute this. So it says that number of sales we can expect is 10.032. That is around 10 sales we can expect. So this is how the linear regression model will work. Now let us see how well our model actually is predicting. So here what we can do is that this is a linear regression model we created. We can use the predict function to predict the output for a given data. Our training data is an X train, so we pass this training data and we will collect the output in this variable called y train pred. So let us just run this and I am printing out the first 5 values of the predictions. So this is here. If you want to see all the predictions, you can see that as well. So you can just say y train pred and these are the predictions for all the training data. Remember, we had 160 training data. So I will remove this. So the first 5 predictions are here. So let us compare this with the actual data. So here we have the first 5 actual number of sales which was generated. We see that there is an error. So the first prediction is 13.44, whereas actually the number of sales was 11.0. Similarly, the second prediction is 16.82, whereas the actual sales was 14.8 and so on. Now to measure what is the degree by which our prediction is correct, we can see 2 metrics. One is the mean square error. Mean square error, like I told you, it will give you the difference between, it will give you the actual error what has been caused by our prediction. That is, these distances, what is the error? We can square up these distances and see what is the actual what is the actual amount of error our model is creating. So this is the mean square error. Another measure is R square. Now R square, if the R square is close to 1, that means our model is performing pretty good. As close it gets to 1, it is better. More far it gets from 1, the model is performing much poor. Let us see what is the values we get for our model. So here we see that our mean square error is about 5 units and R square is about 0.81. So this is a pretty good model, though it can be much better also. So now let us see the predictions what we get on the test data. So here, instead of the training data, I'm passing the test data and collecting the predictions in another variable called y underscore test underscore pred. Let us see the first 5 values of our prediction. Remember, we have 40 data points in our test data. So here you see the first 5 predictions, what it is making on the test data. We can find out what is the goodness of this predictions by finding the R square value and the mean square value like we did on the training data. So on the test data, our mean square error is about 6.1 and the R square is about 0.80. Now, one thing to notice is that the R square on the training data is higher than the R square on the test data. This is expected because the training data is the data on which the model is prepared, whereas test data is not seen by the model. So he is expected to make more errors. However, these values are pretty close to each other. These are not very far away from each other. So in that way, the model is not very bad because it is trying to predict unknown data pretty consistently. we say that it has got less amount of bias and variance. Now, once we have made the model, we will be utilizing the model in real life by giving him data. So let us say that we give him a data. If I place 200 advertisements on television, what is the expected number of sales? This is the way to do it. I can use the model and I can use the predict function, passing the data to him. So it says that if you place 200 advertisements on television, you can expect about 18 sales. So if I change this, let's say I make it 122 and see what it says. It says that if you place 122 advertisements on television, you can expect 13.7, about 14 sales you can expect. So there we saw that how we can make a linear regression model using one independent variable. Next, let us see if we have more than one independent variable, then how to make a linear regression model. So here what we will do is that we will use three variables, that is all the data that we have. That is, we have data regarding number of advertisements placed on television, radio, and newspaper. And our dependent variable is the number of sales. So from our data frame, if you see our data frame, I will just show it to you once again for memory purpose. If I say df.head, so notice that we have got three independent variables and one dependent variable. So from this data frame, if I drop the sales column, then I get a X, that is this much amount of data. That is this all data from all these three columns. And the Y will be the fourth column, that is the dependent variable, that is sales. This is what I have done to create our X and Y. Now, similarly, we will split our data into training set and test set. Again, we will keep 20% of the data for test and 80% of the data for training. So I do that. I should have run this first. And now I run this. This works. So now on this training data, that is X2 train, we will create our linear regression model and we will fit it. So there the linear regression model is created. Now, if you see the intercept, we will get an intercept that is this much is the intercept, and we should get three coefficients now because we have three variables in our independent variable set, that is TV, radio, and newspaper. So we get three coefficients. This is the coefficient. This is the slope for number of TV advertisements. This is a slope for number of radio advertisements, and this is a slope for number of newspaper advertisements. So from these coefficients, we get that our equation becomes, this is the intercepts 4.714 plus 0.0545 times number of TVs plus 0.0100 times number of radio advertisements plus 0.004 times number of newspaper advertisements. So here, just like before, if we consider that we have TV ads equal to 56 and radio ads equal to 15 and newspaper ads equal to 23. Then the sales will become equal to 4.714 plus 0.0545 into 56, that is this one, plus 0.1 into 15 plus 0.004 to 23. So this will be the number of sales. So we can compute this. We can just copy this and ask Python to solve it for us. So notice that we can expect 9 units of sales in this situation. So we can, instead of calculating like this, let us use the predict function on the linear regression model and see what is the predictions we are getting on the training set, and how good the prediction is we can make out by the R square score. So you notice here that the R square is about 0.90, which is a pretty good prediction. So here the model has improved after we have increased the number of independent variables. We can also check the R square on the test data. So notice that R square on the test data is also about 9.90. That means we have made a pretty good model. So once we have a model of this nature in multiple independent variables, we can give the number of units of television ads, radio ads, and newspaper ads, and ask the model to predict for us. So this is what we will utilize. So if we place 200 advertisements on television, 10 on radio, and 50 on newspapers, then we can expect 16 units of sales. So that concludes our discussion on the linear regression model creation using Scikit-Learn. Thank you.